Okay. Good afternoon. Today we are going to review the previous one, and we are going to also talk about new subjects here. So as we have here, we say that we have a tautology and contradict and contingency. Yes, thank you. Oh, I skipped. Checked. Do you remember the tautology? What was the tautology? Yes. When, if and only if, be true. Thank you. So yes, 10 off, thank you. 10 off all. Yes. Good. Now we have a tautology and we have a contradict. How about contradict if all are false? Thank you. And for example, we say the simple example to understand P and negation P will give you false. P or negation P will give you what? Will give you false. Good. So we have two things. Here's the definition of the tautology. And here you can see everything is clear here. Now, did we do this table? I think we did like that. We did this table together. Good. And also that one is, you can see from here, you can directly say this one is these two are equivalent. Why? Because each number, each sentence, each proposition are equal, right? Good. Now, how about this table? We talk about this table. If we have three cases, how many digits, how many rows do we have? 8. How? Depending on the 2, right? Base 2. So 2 to power 3 means that we have 8. And we have this table. Okay. So I'm not going to memorize all these one here. So how we control them? How? You can find, for example, I say P and T, right? So how we know P and T is equal to what? We say P is maybe true or false. And we have tautology, of course. TT means that tautology. Then, and between them, true will give me true, false will give me false. And I got what? I got P itself. Am I right? Clear, dears? So each one you can solve by this concepts. For example, I'm going to find another one for you. You know, that one means that as we have it before. For example, if I say A plus B equal to B plus A, am I right? This property is called commutative or symmetry. So here you can see between or and we have a commutative law. Understood? So how about the 3-1? If I have A plus B plus C, we say that in the previous, for example, Cal1, college algebra, whatever you call, we can see is equal to A, B, C. That one is called associative, and go on. And as important things we mentioned here, the De Morgans. Do you remember what was the De Morgans? If you put the negation to the P and Q, you'll get negation P or negation Q. So it means that when you say we have a De Morgans, we have a negation rules, P or and anyone that you like. I know that one is equivalent to what? Negation P and negation Q. And I think that one is clear. If, for example, during the exam, if I say, show me how do you solve that one for me? Truth table. Go bring truth table, and you'll see the location are equal. And the result are, let me say, same, not equal. The same thing is true for here and there. Everyone has the name, but I don't care about the name. For example, if you forget about P, you say, I forget about P or Q and R. Can you tell me the result of that one is equal to what? Or that one is equivalent to what? Hello? Yalla day? It's easy. I can say equivalent to P or Q and P or R. Why? We call that one as a distribution. Distribute that one to here and there. For example, if you forget how to do it, just think about that one. If I have multiplication A plus B plus C, I'll get what? Huh? I'll get A, right? C plus, B plus A cross C. Am I right? So change that on to and or. So you don't need to memorize it or change that onto or and. What do you mean by that? Now you know, I mean. And the previous one, what do you have? Or. So now I'm going to change it to and. P and Q or R equivalent to what? Yalla, use the distribution. Yeah, P and Q, right? Or P and R, you are right. Understood. Easy. So you don't need to memorize it. Distribute it like a number, like a operation. So here's that one's called operation in algebra. That one is called operation in the logic. So you have the same rules. Understood, dears? Good. So that's all what we have here. And how about the conditional here? We say that one. This one is very important. We are going to use that one a lot. Clear, dears? We are going to use that one a lot. As well, we are going to use that one a lot. And the rest, I'm going to leave it for you. Maybe we need it, maybe we don't need it. Depends. So in each case that you want, you don't need to memorize them. Just use them. Understood? How? For example, I say show that without truth table. Listen to me. My question is what? I say without. Yeah, without truth table. Show me or show that one, for example, this proposition equivalent with the other proposition. So what do you mean by that? How to answer that question means that do not use the truth table, just use the property. Which property? Those property that we have here and there and there. Understood, dears? All of them important, but that one is useful. You use it a lot. That one will be used a lot. And of course, De Morgan's is used a lot. Of course, distribution used a lot. That's it. Understood. So these 4 and 5 one, we are going to use them a lot and a lot. So to understand, go to one here and look. Show me these two are logically equivalent. What do you mean by logically equivalent? It means that show me by what? Without truth table. So how we show? So now we are going to use these one. I have negation P then Q. Am I right? I want to show that is equivalent to P and negation Q. That's my question. Show me without truth table. So I know. I see negation is equal. Let me that one. P implies Q is equal to what? I see is equal to, I don't know. I don't know. Is equal to what? Negation P or Q. How do you know that one is equal to that one? Because we have a table in front and you can use the truth table to understand. Did you get the idea? Instead of using truth table, I use this property. Where did I bring that one? From here. I told you that one is important. Good. Now, and I know by De Morgan's, we have what? Negation P and negation Q. Am I right? That one by property, that one by De Morgan's. Do you have a question? What did I do? I distribute this negation to them, and you know, you will change from and or to or to and. Then negation of negation is equal to what? Itself, not false, itself, right? P itself and negation Q. So you can see I showed if I start with here, I will get there with using truth, no, sorry, without using truth table. Do you have any question, dears? Good. So later I'm going to show or share this video with you. Good. Did you understand how to use that one? Clear? Good. Now, the second example. Look, show that that one and that one are equivalent. Yalla, help me. Negation P or we have negation P. Yes. Negation P or, okay, what else? Negation P and Q. negation P and Q, A equivalent to what? P negation Q. Am I right? Sorry. Negation P or all of them. Okay. Right? Good. Clear? Sorry. And. Okay, okay. Good. Tamam? Shall we start? Yalla. I should start from the left side to get what? Right side. By using what? Truth table. Okay, Kaka? Take care from here. So I say is equal to what? Negation P and negation of here. Am I right? Hello? Good. Which is equal to what? Equivalent to what? Negation P and negation P. Okay. And change to or, you are right, negation Q. Am I right? Then I will get what? Negation P and P or negation Q. Clear? Hello? Did I do any mistake? Can you check for me? Good. Then I'll get what? Negation P, now it's a distribution time, distributing. And P, A, or negation P, or, sorry, and negation Q. Am I right? Clear? Any question? Raise your hand kindly. Why? Where? No, we say distribute that one. Your question is here? So we distribute that one, or you got it? We distribute it. Good. Yalla. Negation P and P. When he says zero, he means contradiction, false, right? You can check it. So I'm not going to memorize them, but I know because I have an and is strong. So in that case, I'll get what? I'll get, yeah, false. Am I right? P is true, false. Negation P is false, true. And between this one will be false, false. So I'll get contradiction. Thank you. What else? Or negation P and negation Q. Am I right? So is equal to what? That one? Equivalent to what? Why? Not changing. Exactly. Because we have false or, so not changing anything. So if I have and, will all change to the false, right? So in that case, we have what? We have negation Q. So let me check. That was my question? Yes. So we get the right side. Clear, dears? It's not heavy. Sorry, not complicated. It's easy. You can catch it. Any question? Good. No question. So that's all that you need. You can find all distributions, all rules, step by step here, kindly. So that one will be your homework, of course. Right? It's easy. Just do it at home. And it's important for the quizzes. Your quiz is something like that. Your test will be something like that in this chapter, in this section. Clear, dears? Good. And we select the important one. Now we have the two things here. 1.4. First one is predicting. The second one is very important, quantifiers. Do we get the quantifiers here? For all and there exists? No. Good. We have predicting. Predicting means that you are predicting some point to be true. Or I'll give you the some point, you say true or false. How? We say that. For example, look at the first example to understand. So I'm going to left the second for you. Okay. We have what? P of X is the statement. What's the statement? Is X greater than 3. Okay. What are the truth value? means that it's a true or false. P2 and P4, or P4 and P2. So let me check for P4. So P4 means that instead of X, you have what? This is PX, the statement. So if I put P4, I will get what? 4 greater than 3. So that one's true. Yes, I say it's true. How about if I put P2? 2 greater than 3 was false. You got it? That one is called predicting. Clear? Clear, dears? So I'm going to leave that one for you. What's the difference between this example and the previous one? That one is sada, that one is what? Biryani, right? What do you mean? It means that we have two numbers. It's not different. Not hard. Just do it. Okay? You should think about this example. Do you have any question? Yes? So quantifier is very important. Quantifier and this rule later will help you to understand the theorem. When I give you the theorem to understand. When you have a theorem and you understand, you should solve it. You should prove it. So how to prove it? So you collect all this information, and then now today you are busy, you are not in the good mood because we have a quantifier here, truth table here, equivalent here. But later we collect all of this information to use in the last section. How to prove. So kindly listen. We have two quantifiers here. Then later we have a mixed compound of them. The first quantifier here we say is for all. For all. Quantifier is called universal quantifiers. Okay, Kaka? Okay. Quantifiers. So put your mobile away and be here. So quantifiers for all. And sometimes we symbolize like A, upside down A, reverse A, reciprocal of A. Understood? So that one's called for all. Means that there is no point. There is no, it should be 100% true. Or when I say for all, should be 100% false. There is no any point to leave it. When I say all these students here, they finished calculus 2, I should be 100% sure. That's why I say for all students in discrete mathematics, they finished Cal 2. Am I right or not? Is there any student not here? They didn't go to the Cal 2? No. So when I say for all, means that. Understood? When I say I mix this student with the other department, I say maybe there exists one student, or we have a guest. Let me say this class is for all. Some guests come to here with you, is your friend, okay? Kindly take care. Aro, put your mobile away. Yalla. If you have do it. Yalla. For example, one guest has come to Kaka Aro, okay? And sit with him. We say all the students took the Cal 2. Am I right now? No. There's some students, the guest, he didn't or she didn't took the Cal 2. So in that case, you see, there exists one guest, one element, one student that didn't get the Cal 2. Understood? So that will help you to prove or disprove me. Now I say for all students here, they finished Cal 2. I am right. You should prove it. When the for all is right, that will help you to critical thinking, to write coding nicer. So when you see for all, you should prove it if I am true. When I am not, my theorem is not right, it's false, you should bring at least, let me say at most, one element, not at least, at most. Means that if you bring one value which I'm not right, so means that you disprove it. These concepts we are going to use later. Careful. So if the theorem is true, for example, if I say 1 plus 1 equal to 2, that is for all right. You should prove it, show me by the methods. When I say P implies Q is equivalent to negation P or Q, you should show me, prove it. Understand? But when I say P and negation P is equivalent to P, just bring one example for me that I am not right. Understood? One example. I think maybe we lost the recording. No, not about that one. I can record by that one with this 2 hours or more. Huh? No way. So, yalla. Later we know. And actually, I didn't use the OBS because with the data show maybe that doesn't record it. That's fine. Okay. Anyway, yeah. Where we are? Yeah, PSG. Yeah. For example, they say I created a theorem. So they invite many people, many mathematicians. They say, if, for example, I have n is odd, n square also odd. So I put this theorem in my mind and I publish it with you. So kindly show me I'm right or not. So everybody try to bring one example to make my statement, make my theorem false. In case you find it, okay. If you don't find it, I'll get a PSG. After 10 years, if you bring an example which make me false, make my statement false, you will get a PSG. My PSG will take it. It was in the previous age, it was like that. So for all, it's very important. Also, there exists very important. For all important to show you are 100% right, and that one is fact. There is what is bringing one example that make you sure you are not right. Understood? One example is enough for showing you are not right. So later we are going to prove that theorems later, but not now. So for bringing that on, to getting that idea, from now you should take the quantifiers like for all universal, and there exists existential is called. These two are very important. Understood? Both of them are important. So I'm going to the example to know we need them. Here's the symbol, the domain, for example, they say for all x. We say for all x. If I say for all x in the R, means that all real numbers, right? When I say for all x in positive integer, means that from 1 to till infinity. I mean that one. If your example, bring it from 0. If your example is minus, does not include my statement. Why? Because I say for all x in where? In positive integers. Understood? Good. So you can see from the example here. Say what? Let P that statement. So show me. Now the domain is what? All real numbers. So show me that one is right or not. Look, the statement. Here's the first example. Here's your statement. We have what? X greater than 1. X plus 1 is greater than x. You say what? For all x where belongs to real number. Means that any numbers. So can you bring one example to show me that one is wrong? Is there any example? This example is called counter example. Later we'll get it. Counter example. So do you have any example? Hello? No. Huh? X in real number should be exist number. Square root of 2. Pi. 1 over 2. 0. Minus 1. Which number do you like? So every these number plus 1 is greater than itself. Of course, yes. So this one is true. So it means that the statement is true. Okay? You got it? Good. So that's that for all. You can see for all students, for all x. So kindly think about this example. Okay. Example number 2. So on that one, table 1 is what? Is tell you The truth should be true for every, all. For all, every. Things should be true. How about the false? Bring one example, which is not true. One example is enough. How about for there exist? Existential means that just only one, at most, just only one is true, only one. Or only one is false. So for showing I am wrong, bring all things. Now, forget about table one. Later, I'm going back to them because we have a negation. That's why. So I'll give you did you understand this example? Can you read that one? Q of x, okay, is your statement. So Q of x is what? X less than 2. That's my statement. Q of x less than 2. X less than 2. Am I right? Good. What's the truth table? For qualification, for quantification, which quantification? For all x, okay, the domain consists of what? Real numbers. He say for all x belong to real number, this Q, show me, is true or not? Yalla. If you have x less than 2, that one is true for all real numbers? No. Give me one example, that's enough. For example, 1, 0, minus 1, minus square root of 2, whatever you like. So minus 1 or 1 is not equal to that. So the result is what? It's false. You got it? Bring one example. When I am true, means that true. When I am wrong, bring one example. You got it, dears? So that means what? You bring one example in real number with x such that x is equal to 2, then Q of x is false. You got it? One example, that's enough. Any question about, yes, Kak? Yeah, so 2 is not. Yeah, you are right. Sorry. So 3. At least bring the one number. Well, in my mind it was greater. I don't know why. So 3. Yeah. Yeah. Which example, kindly? Later we'll discuss. No, you're wrong, but later we'll discuss. No, later we'll discuss. Okay? Later. I don't have the time, I'm recording. So later we can discuss, no worries. During the break that I'm going to give. Okay, dears? Understood, Kaka? Question. Example 11 is the English one. Just read it for you. It's good. Make you to understand more. Existential, which means that by there exist, and the existential can be symbolized like that, and we mean that there exist. Just we mean bring to one example, and the negation of them is important. Here we are. I have 2 negations. Now, for example, I say negation of for all x, p of x is equal to what? The negation of that one. Equivalent to what? Yalla. We say there exists x negation of p of x. How about the negation of there exists for all proposition? We say equivalent to for all x negation p of x. Understood, dears? That one's called negations of quantifiers. Clear? Good. Question till here? No. Just look. Just look at them. Good. He say what? He say if you have that one and that one, kindly find the negation of them. I have what? For all x, x equal to what? X squared greater than x. How about negation of here? Dears? Yalla, that's a p that we have. Negation it. I'll get what? There exists x squared, what? They? Smaller or equal to x. Clear? Hello? No? Sorry? Okay. If something, I say greater, silent please. When something is greater, the negation of greater is what? I say, for example, x greater than 1. Negation that one. I say x less than 1 equal to 1. Right? My x here is greater than 1. So the negation of here, the complementary of that one, I say maybe 1, maybe less than 1. You got it? Now it's clear? Good. Disproof. Good. Okay. Proof or disproof? Okay. Later we will decide. Understood? Good. Any question? Good. So he say what? Show that and that are what? Are logically equivalent. Can you show me that? Yalla. I'm going to do it right here. So I say negation of for all. Sorry. Yalla. Negation of for all. I say negation of for all x p then q. So how we find the negation of that one? I say equivalent to negation for all x a negation p or q. You know why? You know why? We use the property. Then negation of there exist of for all will be there exist x. Negation of p. Am I right? And I'll get what? There exists p and negation q. Clear? Clear, dears? Come to here. Come to close to me because every time. Good, Kaka. Seika. We have what? You say what? Find the negation of all x, p then q. Show me that one is equivalent to what? To there exists x, p, and negation q. The question is like that. Show me without truth table. So it's easy. I say it's negation for all x. P then q is equal to what? Negation p or q. We did that before. So I'm going to negate the quantifier. You see, the negation of the quantifier for all will be there exists x. Am I right? And negation for p. My p is here. Understood? Then we are going to use the De Morgan's law, right? So is equal to what? Negation of negation p. Okay. Negation of negation p and negation q. Am I right? By De Morgan. So there exists x, p, and negation q. Did I get the left side and with the right side? Did we show that one? Yes. So is that equivalent? You got it, Kaka? Good. Question. Hello? Are you fine? We have nested. What do you mean by nested in English? What? Yeah, like a nested of the, yeah. No, we don't have a list. Understood? I'm give you the rest, but doing this correct time. Wait. So, or let me give you rest for 5 minutes. That's better. 5 minutes, sorry. Yalla. Quick. Remains 4. Remains 4.